Welcome you to my another video about electrician's tools. Today, with cooperation with GVDA company, the GVDA GD300 soldering iron. They may have sent me the iron to make a review on my primary Czech channel with significantly more subscribers. But hey, it's a soldering iron anyone worldwide would have use for. So why not record English video too? For you guys who don't understand Czech and still want to see this soldering iron in action. First, let's quickly clarify what principles do soldering irons work at, since 65 watts is not the same as 65 watts if you compare, for example, directly heated tip with indirectly heated tip. Soldering irons are generally as old as maybe 100 years or so. In 1941, however, Mr. Weller has made the first transformer soldering iron. This is Czechoslovak soldering iron, yeah? Not the Weller one. And he patented the transformer soldering iron in 1946. These transformer soldering irons have been made the same almost until today, and there is nothing to be evolved. This iron was made in former Czechoslovakia. We have tons of these here in Czech Republic and also in Slovakia, because in Soviet era there were communists here and everything was in short supply. Everything, even dirt was scarce. I may have exaggerated that, but in these years transformer soldering irons were cheap to manufacture and they didn't require almost any technology. And they were just sturdy, durable pieces of iron and copper. So it was the only option available for masses. They were also used in the West. You may actually remember something like this, but you may also remember that they weigh like a dumbbell and they have tendencies to overheat the tin, so it would oxidize and not be useful and must be tossed. They also have a short lifetime of the tips, as they are made of 1.5 mm squared copper wire. 11 centimeters if you have screws, or 8 centimeters if you have these nuts with these calipers. When you turn them on or off, the shorted secondary winding made such a strong electric field around here that you would kill any nearby MOSFETs, any CMOS logic, etc. The only bright side was that they had a bulb and they were powerful. This here in former Czechoslovakia, 125 volt amp ones were most common, just like this one, which is way higher than the power of today's soldering irons. Then came these pen dump soldering irons. I hate them the most. They are the worst piece of garbage. They had indirectly heated tip, which means there was heater and there was changeable tip, and there was one screw or 3 screws sometimes, and you would just have to insert the tip and tighten the bolt, and the heating element was around here. The best were copper tips, but people usually made tips from nails, and since steel ain't as conductive as copper or aluminum, they soldered very badly. They usually had 40 watts or around that, and regulation was done by you either turning on and off your power strip just like this. It's too hot, it's too cold, it's too hot, it's too cold. Or you could be shouting at your friend who was turning the circuit breaker on and off, or you could even regulate it by just plugging and unplugging the cord. These were either too cold or too hot. There is no sweet spot when using these pieces of garbage. Then came first regulated soldering irons. Well, this one is quite new. It was just power regulation, just like we have here. So there is no temperature regulation. So your left hand was like PID regulator, and you just had to keep turning the knob depending on what did you solder. These were also indirectly heated, but the one I have here is quite modern, so it has M4 threaded tips. You can also find them on AliExpress, because M4 threaded tips are still unfortunately quite common today. And if you own one of these, it's good practice to use graphite paste on them, because they sometimes have tendencies to tighten themselves up and you won't be able to get them out. Temperature regulation, finally. Here in Czechoslovakia we had ERS50 and ERS50-100. These were available only for laboratories and factories, and if you were communist. If you were just a hobbyist, you would have to stick to transformer iron. And I have this example here, again quite modern, from AliExpress, and derives thermistor that senses the temperature of the heating element, and the electronics compare the actual temp from the thermistor to the set temp, and then the electronics behaves accordingly. It either adds or just waits with the power. This is ceramic heating element iron, the almost pinnacle of indirectly heated tips irons. They were okay to work with, but they had their flaws. The biggest problem was again heat transfer. Just like with any indirectly heated tip systems, there was huge thermal resistance between the heater element and the tip. If you were soldering small SMD components like SOT23 or 0402 or smaller THT components, well, it was actually okay, no problems whatsoever. But more massive components like XT60 connector, like this one, well, this was a huge problem. And there are far worse systems like Solomon system, where the tip to heater distance is like 5 centimeters. That's insane. You begin soldering, set your temp to, let's say, 340, then you touch something, and the tip instantly goes down to 290 degrees. The actual reason why JBC and then after them Hakko came with the directly heated tips. JBC is from Spain, I believe, and Hakko is from Japan. For example, I have this Hakko T12. It's all-in-one solution. Tip, heater, and thermistor in one assembly. Around here, with perfect heat transfer between all of them. Thanks to this, you can be running at low temps and solder without overheating your soldering thing that would then oxidize. When I was using my 900M indirectly heated iron, then for like XT60 connectors, I had to set the temp for at least 380 degrees Celsius, and this was the minimum. But at this temp, the tin began oxidizing just after a few seconds. Few seconds later, even resin flux couldn't save the situation, and I just had to clean the tip and add new tin. With directly heated T12, I just leave it at 350, like almost all the time, or 340, depends. Yes, for tiny SMDs, 320 is okay, and for more massive connections, 360, maybe 380 is great. But having just these 340 degrees significantly prolongs the tin life and also tip life. There are also some derivatives coming from T12 system, and it is SH72 system, which is the same but significantly shorter, with different position of this ring. And then the derivative that we use here in the GVDA GD300, which is T65 tip. And T65 is even a little tiny bit shorter than the SH72. They are, however, interchangeable because the position of the ring is the same. If you begin from the machine end, then this position is the same. So they are absolutely interchangeable. If you would like to use Hakko T12 tip in GVDA, you can, of course, but you have no option to lock it with the nut. So that may represent a problem, but still it's possible for you to grab a shovel like this and desolder some heavy ass components with it. Special case are short circuit soldering tweezers and gas powered irons. I have two of these gas powered irons. The branded Portasol, it died quite quickly. The Parkside from Lidl is still working, although not that perfectly, but it works. Definitely. Gas powered irons are great for soldering on the go, or at least used to be before GVDA came up. But the gas consumption is quite high, so it's not that economic. And secondly, there is catalytic burning, not flame burning. So the catalytic burning has very hot exhaust fumes, many hundreds of degrees Celsius. So it's quite frequent that you burn something near the exhaust, even your fingers or your hand. And believe me, I have my experience, and quite rich experience. Soldering on a roof, soldering a connector on high ladder, or soldering in cars. Almost every time I soldered something, I burned something with the exhaust fumes. So these ages are finally over. The GVDA GD300 came to the rescue. Did it? It's almost as portable as gas iron. It has directly heated tip, just like Hakko or Kasagger, and looks to be good. Is it? that's the subject of this video. Let's have a closer look at the tip system. The legacy system was Japanese Hakko T12. Chinese manufacturers then recognized it as worth trying and began producing them too, and also many stations that would use them. The best known is KSGR T12. KSGR costs like $75, so it's dirt cheap, and also the best in under $400 class, I would say, or at least used to be when I was buying it. The T12 system is so well designed that some Chinese companies began producing shorter variant SH72. It has the exactly same heating element, 6 ohms, and exact same thermistor. GVDA GD300 uses T65. That is even shorter, a little bit shorter, like 10 or 12 millimeters, I would say, and the shorter tip means smaller dimensions, which is great for such a portable iron, but the compactness also brings two darker sides. There is a reason why Hakko made them so long, and the reason is thermal resistance. You want the lowest thermal resistance at the soldering end and highest thermal resistance at the handle end. Otherwise, the entire handle would become hot, and there are even some cases when irons have actually melted their handle. It was definitely bad designs, but it has shown that the tip to handle distance really matters. As I have been using this iron for a few weeks and I have soldered like more than 10 meters of soldering wire, I can say that T65 tips are the borderline. When I was soldering for a long time, like 2 hours straight, the iron got a little warmer. Well, the fastening thread is made of brass and the body is made of aluminum, so it cools itself off quite effectively, but I could definitely feel it getting warm. So the T65 is the most compact but the shortest length that's still acceptable yet. Was it 1 centimeter shorter, it wouldn't be comfortable to hold the iron. Because of the shorter tip, the iron has limit to 420 degrees Celsius. I must confess I haven't used the iron at such a high temperature, as my maximum was 380, because that's like the hottest temp you would actually need with directly heated tip anyway. But if you would plan to solder big masses, I would think of buying SH72 tips that are approximately 12 millimeters longer. T12 tips are made in many more shapes than T65 or SH72. So what if I wanted to solder like entire 10-pin connector? There is one magic word that always makes things a lot easier. The word is compatibility. You can grab such a shovel. Well, I call it shovel because it's actually shaped like shovel, but it's T12-I402 tip. They make them even wider, but this shovel is wide enough for me, so I use this one. You can just grab your special T12 tip, whatever it is, and you can put it in your GD300, and guess what? It will work as a charm. Oh, come on. Yeah. Now we are heating. Where is my tin? Here. So let's prepare the tin. We are still heating. This is T12 tip, the shovel type. Now we may be able to, yeah, the resin melts just perfectly. And now we are at 341. Oh man, look at this. Look at this. Beauty. So, the magic word, compatibility, is the word that makes your life much easier. So, having your soldering iron running at quite standard tip system and being fully compatible with other tool systems is such a relief and definitely comes handy. And the last thing in this chapter, GD30 has power of 65 watts. I remember when I was a student in high school, we had these 60 watt indirectly heated soldering stations, and I was losing my nerves on them. I was becoming feral when these 60 watt pieces of dirt couldn't solder a little more massive THT component properly. These were Solomons, I believe, and I promised myself that 80 watts is the borderline minimum for me, and I promised myself to never put less than 80 watt soldering iron in my hand. And now I am holding 65 watt iron, knowing it's perfectly fine. That's the spirit of directly heated tips. From my experience, I can estimate that this 65 watt directly heated GD300 would be fully comparable to approximately 80 to 100 watt indirectly heated soldering station. No kidding. And this approximately 100 watt Hakko T12 would be comparable to 130 watt indirectly heated whatever. So the directly heated tips for the win. The soldering iron can be bought in many packagings. The basic is just soldering iron, K-tip and cable, alongside with starter tin and this holder or stand made of sheet metal. There are some other kits like with tips, 4 more tips, which comes handy because there is the BC3 tip, which is my favorite. I use BC3 tip for almost all the work. Then there is kit that comes with the charger, and I would personally recommend the kit which is like this. This is my personal recommendation because, well, you have the charger. If you calculate the prices, then you will come out to the conclusion that it's actually more economic to buy it with the charger or the adapter, because the price difference is so low for such an adapter, which is good quality. But there is one problem. Since I am from Europe, I'm European, we use these French sockets. French type sockets, but we Czechs and Slovak, we have live on the left preferably, meanwhile French have live on the right preferably. So this is the problem, since this is not from Europe, this is a foreign country, I believe USA or whatever, uses these, and there was an adapter to this adapter that adapted it to Czech socket or French socket or Slovakian socket or whatever socket you want, and also German Chuku socket, which is similar, but it has broken like by itself. I wasn't wobbling it, I wasn't applying any force on it, it just fell off and broke. So I have this adapter that goes right on my adapter, and then it can adapt to Czech socket or European socket. But it's the only bad thing about this adapter, since when I was soldering for like 2 hours straight, there was just slight warm-up at the sides, but nothing more. It was absolutely fine. Such a starter soldering tin may come handy if you have already ordered some bigger packaging of your soldering tin. For example, you have already placed an order for like a half kilo of soldering tin, or 1 kilo of soldering tin, or 100 grams of soldering tin or whatever, then this may come handy before this arrives. And also it's like a travel a travel soldering tin, so you may use it on the go, but you are quite limited with the grams here. But it doesn't matter, since this is quite convenient. I mean, you can like pull it from it, and yeah, it's convenient, really. The quality is okay. We will compare it in the part where there will be soldering under the microscope I own, and we will be comparing it to my daily Cinel SN99.3 CU 0.7, which is classic lead-free tin with resin core, so it's halogen free and it's non-corrosive. It's good for stranded wires and PCBs and everything. It just doesn't corrode anything. So this is a good thing. You can buy it if you are European. If you are from America, then well, this is Polish company, so you may have some other companies in America or overseas or wherever you live. So I will be comparing these two tins, and I must say before you see it, this tin is okay, definitely okay. As these tips may come handy, that's mostly because of this BC3 tip. BC3 tip, we will see it under the microscope better. The BC3 tip is the holy grail of all the tips I use, even for my daily KSGR T12. I also use BC3 tip. And for this GVDA GD300, BC3 tip is also my number one go-to tip for almost everything. Now I have K-probe. This is not a multimeter. K-tip I have on just because it was actually on the soldering iron, because if you buy just the bare unit with some things, then you have the K-tip on it. So I have it on the soldering iron, so you see what you get if you buy it. But I heavily recommend getting the set with BC3 tip, which is great. Then there is smaller K-type tip. There is this needle, which is, I would say, useless. And there is this like basic cone or something, which is good for SMD soldering too, because BC3 is sometimes too big for your work. So D16, D24, or this ILS, is it? No, it's not ILS, we are not airplanes. I have grabbed the bad one, BC3. And BC2, that's no BC2. That's no BC2. Do I have KS? Yeah. Do I have T12 equivalent? Well, it's similar to this BC1, which is a little thinner than this, but it's very similar. For SMDs, I like to use like D12. You can also buy D12 in a T65. Now, there is this thing, I call it octopus, because it has some tentacles. So it goes like this. It can hold like your PCB or your wires or anything, any components you want to solder together. It can hold them quite firmly. It's just enough for PCBs like up to 10 by 10 centimeters, because bigger, no, 10 by 10 maximum. Yeah, so any smaller PCBs, any components, smaller, if you want to solder like wires all together, then this is the way you can do it easily. I would also recommend you getting a vise for your table, because it's wise decision to buy a vise, because it comes handy even more often than such an octopus. But that's only my personal recommendation. You can buy the octopus, it doesn't increase the price that much, and it also includes this sponge. You have to wet the sponge, and then it's it should be for deep cleaning like this or like this, I don't know, because I have never felt any attraction towards sponges. I use this wire, how do you call them in English? Just this wire thingy, which is significantly better than a sponge. It also comes with a GVDA soldering station. If you remember, GVDA have soldering station with 900 M tips, and it has in default such a wire thingy in it. So that's better solution than a sponge. Let's get to the iron itself. Where to begin? At the end. The iron has Type-C connector combined with power delivery protocol negotiation and quick charge protocol negotiation. So it's comparable to, for example, TS80, which I don't own. I have, however, worked with TS100, and I hated the bolt you have to tighten or loosen to change your tip, because you would be constantly losing your hex key. And the worst thing, even worse than the hex bolt, was the connector. TS100 used a DC barrel jack connector that just kept losing contact all the time, and as the manufacturer didn't ship any cable with it, you would end up trying all your cables until you find the one that works like one-eyed who is a king between blinds. it's so bad. The Type-C connector, it's not perfect, but far better than DC barrel jack, in my opinion. Well, to be honest, I would love XT60 connector, but that would be overkill, so Type-C is perfectly fine. You can just grab any cable you have for your phone and use a power delivery capable charger with sufficient power, or the included, of course. And now what? It even supports quick charge, but I didn't manage to get it over 9 volts. Maybe it's the maximum, I don't know. But for power delivery protocol, it will try the highest voltage possible, so 20 volt is the target, unless you specify some lower. So you need a power bank with at least 65 watts, right? Take this. Let's imagine you have only your standard power bank with you. Well, this one is not standard because it grabs 21700 cells, your own cells. But let's say you only have standard power bank with you. This is litho-cola power bank capable of 18 watts. So let's try the power bank. This is the working voltage. We can also see the voltage here. There is, however, one problem. I don't know whether it's the cable or it's the power bank, but sometimes I feel like screaming because the power delivery doesn't work. Oh, 9 volt, 12 volt. As you can see, it's going like 2 amps. And the power bank is only capable of 18 watts, which is 12 volts, 1.5 amp, not 2 amps. So it dropped the voltage and turned off. That's the only solution so the power bank can preserve itself in a working condition. So, and there is the problem. The heating element has 6 ohms, so at 12 volts it wants to have 2 amps. But the power bank is not able to provide 2 amps. So the power bank would be just turning off. Not exactly, because in the menu you can set the preferred working voltage lower, like to 9 volts. Now the soldering iron will try to negotiate maximum of 9 volts. 9.1, 9.2. Now the maximum the soldering iron would like to have and say to the power bank is give me 9 volts. And since the power bank can give 2 amps at 9 volts, then it's absolutely okay. But now the power is reduced, heavily reduced to like 13 watts or so. So, well, it's actually higher because the voltage is slightly higher. Well, 13 watts, you could solder something small with it, something really small. But it isn't perfect. So if you are stuck somewhere with just ordinary power bank, then the power bank is not the solution. The solution is, for example, your power tool battery. The soldering iron doesn't mind getting the voltage without any previous negotiation. So I will give you an example here in Europe. If you are European, you know them. If you are not European, just it's like your Harbor Freight or anything like this. This is Parkside X20 volt battery. It's the same as 18 volts. For lithium, it's still 5S. And I have this adapter that adapts the battery to XT60 connector. Then I have this this adapter that is forbidden to use because, well, attempting to charge your phone through this Type-C connector would your phone may actually explode or something. But I can use this adapter on my adapter to adapt the rails, the power tool rails, to Type-C, not like this, which could have ended very badly. And now I can power the soldering iron from my power tool battery. And the voltage is 20.3 volts. So now I have the full power of the power tool 8 amp hour battery. And I can solder for like half a day maybe from this battery. So this is the solution. If you don't have such a powerful power bank that would provide more than this, significantly more, and these power banks cost a fortune, then you can just use your power tool battery or any DC power supply that would give you 20 volts with approximately 3 amps. No problems whatsoever. Now, the controls, the last chapter before the actual soldering. Once you powered it on, it goes to sleep mode by default. There are 3 modes: normal, standby and sleep. In standby, the heating is set to 100 and meanwhile in sleep it's just off. The soldering iron has an accelerometer, just like your mobile phone, so this is actually even better than KS-jar. If you wouldn't move your iron for a certain time, then it would automatically go from normal to standby, and after then, if you wouldn't move it yet, it would go to sleep. Sleep is also default mode for power on, but it can be changed in the settings. Just pressing left button turns it on if I turn on my power bank. Just pressing left button turns the soldering iron on. There is actual voltage, measured voltage on the Type-C connector, the actual temp, and the set temp. The bar graph above is percentage of power sent to heater, most probably PWM, since one wouldn't fit proper DC to DC converter in such a small case. 3 amps capable or 3.5 amps capable DC converter, the choke would be too big. Short press of any button to set the temperature. What's great is the fact that the soldering iron reacts to the temp immediately and it doesn't wait until the mode is left. So you may be hastily clicking plus 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 or minus 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 before you get to the 420 and the tip would already be at 390, for example. And this is great. It makes the working with it much faster. What is not present, and I would like to have it, is boost mode. My KSGR, for example, has boost mode that increases the temperature by 50 degrees or whatever value you set. This is perfect for cases when you just solder all the tiny shiny SMDs and THTs and resistors and diodes and everything, and then comes a huge chunk of connector, some bit of steel, bit of copper, and it's big and it's cold and you need to heat it up properly to solder it. On the KSGR you rotate the knob to the right, that enables the boost, and you can solder the big chunk of copper or whatever, and then it goes back to normal. But here you have to set a different temperature for it. So I would like it to have the boost mode. Thinking about the controls, there is one place for boost, as long press of the left button is unused. It would be, however, more logical to use the left button to enter sleep state and right button to enter boost state. Unfortunately, the right button is already used for sleep state. And since boost would be time limited, it wouldn't hurt if the boost could go over the maximum of 420 degrees Celsius. That is the limit of this soldering iron. For a short time, I think the temperature wouldn't cause any much harm. Let's go through the menu. It can be accessed by pressing both buttons simultaneously. Voltage info, the actual voltage and tip temp. Then temp step, I recommend, this is the default and it's great. I like step by 10 degrees, but it's your personal preference. Standby temp and sleep time. Your standby temp is set to 100 by default, it's okay. Time delays, preferred working voltage, let's leave it on 20 volts. Temp unit, of course, degrees Celsius, we are civilized. Language, there is only English and Chinese. Rotate for left hand or right hand. Power on heat, I recommend having it disabled, because, well, if you would have it enabled, then the soldering iron would lay on your table or desk or whatever, and it would be off. And then you would power up your power supply or your adapter or your power strip or anything, and it would be laying on a piece of plastic and pfft, and it's gone. The plastic is all melted because you powered it on and you didn't know the soldering iron would heat up immediately after powering on. So the power on heat, I recommend having disabled. Temperature calibration and version info, just for your info. Doesn't go any further, just back. For soldering, I have footage from microscope. There will be no voiceover, so everything is on the screen. I also have to apologize for reduced video quality, since, well, it's a microscope, it's Andonstar AD207, I believe, and it records in full HD, fortunately, but unfortunately it's just 30p, not 60p as the whole video. So the quality may be a little reduced for movements, but still good to have the footage from microscope. So enjoy. Oh. Oh.
Mhm.
So, to sum up the video review and make a conclusion out of it, I kinda like the iron. I like it for being powerful and accurate enough for most of the work I usually do, and you usually do most probably too. It's designed to be used more like on the go than to be your stationary desk soldering iron. Personally speaking, by myself, I solder a lot, and my KSGR T12 and also my hot air gun right there, you won't see it, have been the best friends for that. I would personally not change my KSGR T12 for GD300 on my desk, but I would definitely change GD300 for my KSGR and for my gas iron combo for soldering on the go. In the field, in a factory, on a ladder, just anywhere. Just connect, solder, disconnect. It's as easy as that. Sometimes when soldering in a car or anywhere where there is no desk, then taking whole station with you is not that convenient. And gas irons, they burn everything around them, including human flesh, because of their exhaust gases. This iron, GD300, is just the perfect all-in-one solution for field repairs. And also, if you are not that enthusiastic in soldering, then it may be even your main soldering iron. For me, not, because I solder a lot, but if you would solder significantly less, then this could also serve as a primary soldering iron. But I would recommend it more as soldering on the go. There is like no real disadvantage on this device. Just some suggestions what to improve, yes, that's always. But unlike this iron, that may actually take T12 tips and work at 24 volts. This iron is much better done than this one. These controls of this iron is just awful. So if you see somewhere a listing for this soldering iron, don't buy it unless it has some better firmware or anything. And also, don't ever think of buying this piece of garbage. This 8-watt USB powered useless piece of plastic and whatever the tip is made of. Because we have seen that it struggles even with 0.5mm squared wire, and if you come to soldering like some wires to pads, then it's completely lost. If you are interested in this soldering iron, the GVDA GD300, you can use the link below the video. The link will lead you directly to official GVDA store. So that's all for this video. Goodbye. I wish you no cold joints and no melted insulation, and see you in another video.